All right, let's jump right in. Today, we're going way beyond your typical study guide. Think of us as code breakers. We're here to crack the code on the DP-600 exam for the Microsoft Fabric Analytics Engineer. We're going to find the hidden patterns to figure out what this exam is really asking of you.
So, how are we doing this? Well, we've gone through a ton of practice questions, and instead of just memorizing the answers, we looked for the patterns. The recurring themes, the scenarios that pop up over and over again. It's all about connecting the dots between dozens of different questions. This isn't about studying harder, it's about studying smarter.
I'm going to go out on a limb here and say that if you're watching this, the answer is a big yes. And why wouldn't it be? It's an amazing role, right at the heart of modern data strategy, where you get to turn messy, raw data into these powerful, large-scale analytics solutions.
But that leads to the real question, doesn't it? It's one thing to look at a list of topics, modeling, governance, pipelines, and just feel completely overwhelmed. What's the secret sauce? What are the skills that separate someone who can just recite definitions from someone who can actually roll up their sleeves and solve problems like a real engineer?
Well, that's exactly what we found hiding in the patterns. Turns out the exam isn't just a pop quiz, it's a test of your entire mindset. So let's dive into the evidence we've gathered and start decoding these patterns together. First up, our first major theme, data modeling. And listen, this isn't just about drawing pretty lines between tables. The exam treats your data model like the literal blueprint for everything you build. If you get this part wrong, trust me, nothing else is going to work right. Okay, so a concept that you'll see again and again is the surrogate key. This is classic data warehousing 101, and the exam expects you to know it cold. It's basically a unique ID that the system generates for your dimension tables, your customers or products. The key thing is, unlike a business key, like an email address, it never ever changes. And that's what makes your models stable and super fast. So let's put this into a real-world scenario, the kind you'll see on the exam. Picture this, you just joined a project, the reports are a total mess, and the numbers are just plain wrong. Your gut tells you someone set a surrogate key to be summarized, which is a huge no-no. So how do you find that needle in the haystack without burning hours of your time? And this right here perfectly illustrates what the exam is all about, efficiency. I mean, sure, you could manually click through every single key in your model, but that's incredibly slow, and you're almost guaranteed to miss something. The engineer's answer? The one the exam is looking for, is to use a tool like the Best Practice Analyzer. It's automated, it uses rules to scan the entire model in seconds, and flags this exact kind of problem. See? The exam wants you to choose the smart tool, not the manual grunt work. So, here's the pattern we've decoded. Notice how these core ideas just keep repeating? The exam is practically shouting at you. Use surrogate keys, never summarize them. Use Type 2 slowly changing dimensions to keep track of history, and get comfortable with powerful T-SQL window functions for those tricky calculations. If you can master these 4 patterns, you've honestly cracked a huge chunk of the modeling questions right there. All right, let's shift gears to our second big theme, performance. If data modeling is the blueprint, then performance is what makes sure the engine actually runs, and runs fast. This is where the exam really digs in to see if you're a true problem solver.
And seriously, the hint could not be more obvious. So many questions are framed as a problem to solve. A report is slow, queries are failing, the system is overloaded. The exam is sending a crystal clear signal. An analytics engineer doesn't just build stuff, they fix it when it breaks.
Just imagine this for a second. It's 9 in the morning, your boss is on the phone, and the company's most important daily report has been spinning for 45 minutes instead of its usual 2. The pressure is on. What is your very first move? This isn't just a technical question. It's a test of your whole diagnostic process. This is where you learn to think at different levels. Is the entire system crawling? Then your first stop should be the Fabric Capacity Metrics app to see if you're getting throttled. But if it's just one single query that's stuck in the mud, you need a more surgical tool. That's when you whip out a Dynamic Management View, or DMV. Think of it like a live window into the engine. A DMV like sys.dmsx.requests shows you exactly what's running right now. Different problem, different tool. So we can take all these separate troubleshooting questions and build a kind of performance tuning playbook. Step 1, isolate the problem. Is it a slow visual? Use Performance Analyzer. Step 2, check the whole system's health with the Capacity Metrics app. Then you can drill down into specific queries with DMVs. And from there, you start looking at optimizing the data itself and maybe accelerating things with caching. This isn't just a random list to memorize. It's a logical workflow.
It's the exact thinking process the exam is designed to test. All right, on to theme number 3, governance. This is all about control, security, and responsibility. As an engineer, you're not just a builder, you're also a guardian of the company's most valuable data. You have to know, without a doubt, who can see what, and just as importantly, why. Now here is a classic governance problem, the kind you see in question 15. You want to empower your users, right? You want to give them self-service tools so they can build their own reports. But you absolutely positively cannot let them break the certified single source of truth that you worked so hard to build. It's a tricky balancing act. And the answer is all about understanding the subtle differences between these workspace roles. A viewer? Well, they can't create anything. A contributor? They can change your dataset, which is exactly what we're trying to prevent. The sweet spot, the Goldilocks permission, is built. It lets users connect to your pristine dataset and create all the new reports they want, but it locks them out from editing the original. This is the core idea of governed self-service, and it's a must-know concept. The exam also makes sure you know the difference between security layers. Think of sensitivity labels like a fragile sticker on a package. It tells you the data inside is confidential, but it doesn't actually stop you from opening it. Row-level security, on the other hand, is the lock itself. It's the key that makes sure the sales manager for Europe only sees European sales data. Knowing when to use a warning label versus when to use a lock is absolutely critical. Okay, our final decoded theme is all about automation. Look, building a great model is one thing, but for a real enterprise solution, you need robust, intelligent, and, most importantly, automated data pipelines to keep it fed with fresh data. So let's think about a common pipeline logic problem, one that's at the heart of a bunch of questions. Your pipeline copies some files, processes them, and then it's supposed to clean up those temporary files. But what happens if that processing step fails? You can't just leave those temp files lying around. That cleanup step absolutely has to run no matter what. The key is mastering these dependency conditions. Think of them like traffic lights for your data flow. Upon success is your standard green light. Upon failure is your emergency path. That's when you send an alert. But for our cleanup task, we need upon completion. This is the one that runs no matter what happened before. Success, failure, it doesn't matter. Understanding this control flow is what separates a fragile pipeline from a resilient one. So when we put all these decoded patterns together, a clear picture emerges. It's not about memorizing 100 different features. The DP-600 is testing a specific mindset. You need to model with a clear purpose, optimize everything relentlessly, govern your data with absolute precision, and automate your pipelines with intelligence. These are the 4 pillars of a great analytics engineer. So at the end of the day, the code we've cracked is this. Anyone can learn what a tool does. That's the easy part. The real test, what this exam is truly about, is knowing which tool to pull out of your toolbox for the job at hand, and why. The exam isn't going to ask, what is a DMV? No. It's going to ask, your report is stuck, everyone is waiting, what do you do? It's testing if you know that a DMV is your best tool to find out why. And that's the difference between knowing and understanding. So the only question left is, are you ready to think like an engineer?